Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0615 indicates a malfunction in the starter cut relay diagnosis circuit. This code pertains specifically to the starter cut relay system that is integral for controlling the starting functionality of the engine. In essence, the starter cut relay is a switch that prevents the vehicle's engine from starting under certain conditions, serving as a safety feature. It is typically located in the auxiliary underhood fuse/relay box, which contains various fuses and relays essential for controlling multiple electrical systems within the vehicle. If the circuit is compromised, the engine may not receive the appropriate electrical signal to start, leading to operational issues. Understanding this code allows for targeted troubleshooting, maximizing repair efficiency, and restoring functionality to the Honda Pilot. The DTC P0615 pertains to a malfunction in the starter cut relay diagnosis circuit within the Honda Pilot. The starter cut relay's primary function is to manage the power flow that allows the engine to start, operating like a gatekeeper in the starting process. It is located within the auxiliary underhood fuse relay box, which can be accessed by lifting the hood of the vehicle. A failure in this circuit can prevent the engine from receiving the necessary power to crank, thereby stopping it from starting altogether. This malfunction could stem from factors such as wiring issues, a faulty relay, or problems with the engine control module, PCM. Understanding this DTC enables effective troubleshooting to identify the exact failure point in the circuit. There are several potential causes for the DTC 50615, which can impede the starter cut relay's functionality. One major factor may be poor electrical connections at the starter cut relays or loose terminals connected to the powertrain control module, PCM. These types of issues can disrupt the necessary electrical flow required for starting the vehicle. Additionally, compromised or damaged wiring in the starter cut relay circuit could lead to interruptions in connectivity. Each of these causes can result in the malfunction being recorded as a DTC, and identifying them is essential for rectifying the problem effectively. Therefore, an examination of both electrical connections and wiring integrity is recommended to ensure no underlying issues persist. The symptoms associated with DTC P0615 primarily revolve around the vehicle's inability to start. When this DTC is present, the driver may experience a complete lack of electrical response when attempting to start the engine, indicating that the starter cut relay is not functioning as intended. Additionally, there may be indications of other DTCs that appear on the Honda Diagnostic System HDS, such as P16F3 and P16F4, which pertain to the control circuits of the starter cut relay. As these symptoms manifest, it is crucial to conduct a thorough diagnostic check using the HDS to confirm the presence of DTC P0615 and any related codes that may provide further insights into the underlying issue. The first step in troubleshooting DTC P0615 involves verifying the current status of the vehicle. Begin by turning the vehicle to the on mode, which enables the electrical systems and initiates the DTC check. Following this, use the Honda Diagnostic System HDS to clear the existing DTCs, allowing for a fresh start to evaluating the vehicle's performance. After clearing the codes, attempt to start the engine to see if the issue recurs. It is essential to check for any newly generated confirmed DTCs or pending codes that may offer insights into whether the problem is persistent or intermittent in nature. Should DTC P0615 appear again after this process, further investigation needs to proceed to the next troubleshooting step. In this step, Verify the presence of related DTCs, specifically P16F3 and P16F4. These codes suggest issues within the starter cut Relay 1 and Relay 2 control circuits, respectively. If either of these codes appears in addition to P0615, the next logical step is to proceed with the troubleshooting procedures associated with these specific DTCs. Addressing the potential failures in the starter cut relay circuits could unlock the root cause of the starting issues, ensuring a thorough approach to remediation. This direct correlation between DTCs highlights the importance of comprehensive diagnostics to isolate faults accurately. Step 3 involves a further assessment of potential failure areas within the circuit. Begin by turning the vehicle to the on mode once again, which reactivates the necessary systems to conduct this check. Use the HDS to clear any previously noted DTCs and perform another engine start attempt. Observing the results of this attempt will guide the next steps in troubleshooting. If the engine starts without apparent issues, shift focus to evaluating other components of the starting circuit. However, if the engine fails to start, it indicates a more profound issue persists, necessitating further diagnostic steps. For step 4, the vehicle must be turned to the off or lock mode to safely conduct the fuse inspection. Locate the fuse number B17, a 7.5 amp fuse situated within the auxiliary underhood fuse relay box, and visually inspect its condition. A blown fuse can directly disrupt the function of the starter cut relay circuit by halting the necessary electrical flow. If the fuse appears intact, proceed to the next diagnostic step. Conversely, replacing the fuse is essential if it is found to be blown. Additionally, it's crucial to investigate the circuit for any shorts to ground that might have caused the fuse to fail, ensuring a comprehensive approach to the repair. In step 5, the focus shifts to checking for a continuity issue in the wiring associated with the starter cut relay. Start by ensuring the vehicle is in the off or lock mode before disconnecting starter cut relay 1 from the auxiliary underhood fuse/relay box. Following disconnection, use the Honda Diagnostic System, HDS, to jump the SCS line and wait for over 1 minute. Next, disconnect the PCM connector A, 51P, with both the relay and connector disconnected. Conduct a continuity test between the designated test points, the starter cut relay 1, FAR P socket number 1, and the PCM connector A, 51P number 26. If continuity is present, the STRLD wire is functioning correctly. Otherwise, repairs must be made to the wire between the relay and PCM. Proceeding to step 6, inspect another critical fuse in the system, fuse number C31, also rated at 7.5 amps, located in the under-dash fuse/relay box. The vehicle should still be in the off or lock position for safety during this process. As with previous fuse checks, inspect this fuse for integrity. A blown fuse here can incapacitate the IG1 start cut function, potentially mimicking symptoms of DTC P0615. If this fuse is blown, it's imperative to check for underlying shorts in the wire circuit connecting the fuse to the starter cut relay. Should the wire be undamaged, replacing the under-dash fuse/relay box may be necessary for a complete resolution. Step 7 involves checking for continuity in the IG1 start cut wire. Begin by disconnecting starter cut relay 1 from its sockets in the auxiliary underhood fuse relay box. Subsequently, disconnect the under-dash fuse relay box connector E, 36P. In this step, a jumper wire is used to connect terminals A and B, specifically from under-dash fuse relay box connector E, 36P, number 10 to body ground. This allows for testing continuity from starter cut relay 1, 4P socket number 3 to the body ground. The vehicle status must be in off mode during this testing. If continuity is present, it implies that the wire is functioning properly. Otherwise, observe and repair any breaks in the wire to ensure successful electrical connectivity to start the engine. In the final step of troubleshooting, a thorough evaluation of starter cut relay 1 is conducted. This involves testing the relay to confirm its operational status. If the relay is found to be in good condition, the logical recommendation is to replace the under-dash fuse relay box, as issues could have propagated from that component instead. However, if the relay is determined to be faulty during testing, it must be replaced to correct the DTC P0615 issue. The starter cut relay plays a pivotal role in the system's functionality. Thus, ensuring it operates correctly is essential for restoring the proper starting sequence of the Honda Pilot. For the final repair verification, it is crucial to ensure that all connectors and components have been reconnected appropriately after completing the repairs. Once everything is back in place, attempt to start the engine to confirm that the issue associated with DTC P0615 has been effectively resolved. Following a successful start, it is advisable to use the Honda Diagnostic System, HDS, to scan for any lingering DTCs. This step ensures that no additional codes are present that may indicate other unresolved issues. A thorough verification process provides reassurance that the repairs conducted were effective and that the vehicle is operating as intended. Preventive maintenance is crucial in maintaining the reliability of the starter cut relay diagnosis circuit and overall functionality of the Honda Pilot. Regular inspection of electrical connections associated with the starter cut relay can identify potential issues before they lead to significant problems. Periodic testing of relays and fuses ensures they are functioning correctly and can help avoid unexpected failures. Furthermore, keeping wiring routes free from damage or wear is essential for the electrical system's integrity. Conducting these preventive checks will enhance the longevity of the vehicle's starting system and promote a seamless operational experience. In conclusion, DTC P0615 highlights an important issue within the starter cut relay diagnosis circuit in the Honda Pilot. Understanding the function of the starter cut relay is essential for effective troubleshooting. Effective diagnostics and repairs not only address the symptoms of this issue, but also prevent future failures by implementing sound preventive maintenance strategies. Regular checks of components, wiring, and electrical connections are vital for sustaining vehicle performance. By following systematic troubleshooting steps and ensuring regular maintenance, you can significantly enhance the reliability and longevity of your vehicle's starting system. Please like and subscribe to the channel. See you next time!